A positive point charge is there. No, this isolated positive point charge. Try to see here. So what I took is an isolated point charge. I want to find out the lines of force. I'm introducing electrical lines of force. Electric lines of force. This will be no. I'll keep test charge here. In what direction will expend force? The test charge will expend force in this direction. Similarly, I'll keep test charge here. The test charge will expend force like this. I'll keep test charge here. It will expend force like this. So how to draw lines of force? How to draw the lines of force? Nothing but the force expended by the test charge kept at that point. The direction of that force will give the lines of force here. Let me take the pointer. Similarly, I want the due to point charge. So the lines of force will be directed here. Let me take the point with this one. So these are the getting the idea? This will be okay. Let me erase this. Yeah. Okay, no. So if I draw a tangent on the lines of what are lines of force? Once again, they're nothing but the direction in which, like I'll keep a test charge nearby a point charge. In what direction the test charge will experience a force. So all those locals of all those points, if I join, I'll get a line that is called like a lines of force. They are called as like elliptic lines of force. Fine. Okay, now for isolated positive point charge, I do have lines of force. How the lines of force will be radially outward. Are you seeing this? Radially outward. Then, okay, one more thing. I will look at the spacing between them. You can see this. Point A is at a distance RA. What about point B? It is at a distance RB. Then which distance will be more? RB greater than RA or RA will be less than RB? Then according to the formula, E equal to KQ R square. If RA less than RB, then field strength at A should be greater than B. Okay, now after this, look at the spacing between the lines at A and look at B. Where it is more spacing between the lines, the spacing between the lines is more at B than at A. Spacing, I'm asking you to look at this one. The spacing means or directly you can take this, no problem. So where the spacing between the lines of force is more at B. So therefore, what is the conclusion now? As the field strength decreases, the spacing between the lines of force will increase. Able to get this one? So this will help us to predict to draw the lines of force. Where the spacing is less, they definitely open the field strength is said to be more. You look at the spacing here. You measure this distance. Which distance will be greater? This distance will be greater than this one. So I can say that no, the field strength at A is greater than B. Means where the spacing between the lines of force is less, there the field strength should be more. This very important thing which will help us to plot the lines of force. So this is what I'm trying to insist here. For a point charge Q, how many lines of force I assume? 1, 2, 3, 4, 5, 6, 7, 8. For a point charge 2Q, I should assume 16 lines of force. Any reason for that? Because of this idea. Because the number of lines of force, what I'm going to draw, these are imaginary. Don't think that they're really existing. So why we are bringing this? To express that particular field. To express that particular field open, we are bringing this lines of force. So what are the number of lines of force? They're directly proportional to magnitude of charge. For Q charge, if I assume 8 lines, then for 2Q charge, how many you should assume? 16 lines. No, sir, if a student for Q charge, if I assume 10 lines, for 2Q, you should assume 20 lines. There's nothing called like a number. Not saying number of lines of force equal to. Proportional is what we are writing. You can draw any number. For Q, I'll draw 100 lines of force. For 2Q, you go for 200 lines of force. For 2Q, you go for 200 lines of force. So there's nothing called like the number here. So what we are saying is number of lines of force directly proportional to magnitude of charge. And for negative point charge, we'll see. If I keep a test charge in what direction will experience force towards point charge Q. So therefore, how the lines of force will be directed for isolated negative point charge, the radially inward. So what are the lines of force? How they are? Radially outwards, they'll be directed radially outward for isolated positive point charge. Directed radially inwards for a negative isolated point charge. Fine. There's a thing. Okay, let's see the next condition. One more. One point is being stressed for a isolated point charge. The path traced by the test charge is the direction of lines of force. What do you mean by that? I think I'll bring the complete description. I think you are able to see the total. Now, if I release a test charge here, in what direction the test charge will move? Will move in this direction. If I release a test charge here, how the test charge will move? The test charge will move, will get accelerated. And what type of motion? Variable accelerated motion, increasing speed, decreasing acceleration. The test charge is going to describe. And how do the test charge will move? Will move along the lines of force only. The test charge will not move like this. How the test charge will move? The test charge will move along the lines of force. Means it will be here, after some time here, after some time it will be here. Okay, now let me put it. So the test charge, if I release here, after some time 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 here. This will be the position of the test charge. It will be keep on moving here. And how it will move? Along the lines of force. Similarly, if you release for the negative point charge, earlier it will be here. Then it will come 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 here. So how the test charge? The test charge again will be moving along the lines of force only. So for isolated point charge, the path traced by the test charge is the direction of lines of force. I think it's correct. Isolated strictly, not for it and mentioned for only, for isolated point charge only. Okay, let's come for this one. How the lines of force, if the two charges, if they interact. Now a positive point charge and there's a negative point charge. So what is the force of interaction between them? What is the force of interaction? The lines of force, they will originate at positive charge and they'll come and terminate at the negative point charge. Similarly here, they'll originate at positive point charge, they'll come and terminate at the negative point charge. So how you are able to draw lines of force? So what is the lines of force? If you draw a tangent to the lines of force, it will give the resultant field due to those point charges. if I draw a tangent here to the lines of force, then what happened? The tangent, what happened? So if you draw a tangent to the lines of force, and what it does, it will give the resultant electric field. Sir, why the direction like this? Okay, let's assume that one. Okay, what about the field at this point? Field at this point. Let me go for the smaller one. The field at this point. So due to positive charge will be like this. Due to negative charge, it will be somewhere like this. How the resultant of these two, since E positive will be greater than E negative. So therefore the resultant will come. So let me show this. This is E positive, E negative. E positive will be greater than E negative. So therefore the resultant will come in this direction. So let's come for this one. E positive will be like this. So which will be greater, E positive will be greater. So the resultant will be here. So what about here? E positive, E negative. E negative will be greater than E positive. So the resultant will be near to E negative. So in this way, what about here? E positive like this and E negative also in the same direction. I'll add here E negative, E positive. The resultant E negative will be greater than E positive. So the field will be towards left. In this way, I'll get the direction of field at all points surrounding that one. And if I join the locus of all those points, then I'll get the resultant T bar. So therefore, so what are these? These are lines of force. So what I should call them? What I should call them as lines of force everywhere. This word is missing. Already is written, no? Okay, let me take again the pointer. Okay, agreed. No. So this will be the, so if you draw a tangent on the lines of force, what will give? It will give the direction of E bar. How to predict now the direction of E bar if you know lines of force. How to draw lines of force? Get the resultant E bar and join locus of all those points where the resultant E bar is there, you'll get the lines of force. Both are either way. If you know one, you can get the other thing. No. If I take two equal and opposite point charges, two unlike charges, pointer is there. Yeah. Two unlike charges, I took it. Plus Q minus Q. Then how the lines of force will be given by this one. Now, how many lines of force I took it here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me count it. I don't know. I missed number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I took it. Then how many lines of force here? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how I should know? The lines of force should be equal in number. For Q charge, how many are there? Okay, I'm not very sure. Let me try. I think I'll give a number better. 1, 2, 3. Okay, 11 are there, not 12, 11. Okay, similarly, let me count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'll remove this. This should not be there. I'll remove this one. Okay, 11 point charges, 11 lines of force are there. Why I should take in this way? Because already we made a rule, no? The number of lines of force should be proportional to magnitude of point charges. The number of lines of force should be proportional to magnitude of point charges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here also, if you count it, they are 11. Now, if I take plus 2q, then here minus q. How I should draw the interaction here? So for 2q charge, I'll assume 16 lines of force. Then for minus q charge, I should assume 8 lines. Any reason for that? Because the number of lines of force are proportional to the magnitude of charge. For 2q charge, 16 lines. For q charge, it should be 8 lines. Getting the idea? So like this, we'll start counting the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 lines of force are there. So here also I'm going to count it 1, 2, 3, 4, 5, 6, 7. Yeah, 8. 8 are there. How to draw that one? The lines of force, they'll originate at positive charge. You can see that they'll originate and they should terminate at negative charge. Why not all? No. So how many are there? 8 lines. So some lines of force, I'm showing it. When you're drawing it, you have to take care about the E bar. Again, a T bar here due to positive charge. Like this, due to negative charge. The resultant will be like this. So keeping that in mind, the lines of force has to be drawn. So when you're drawing lines of force, you have to keep in mind the lines of force will be directed along the resultant T bar. If you draw a tangent on the lines of force, it should give the resultant T bar. Keeping that in mind, that will be produced here. If two like charges, okay. If they're unlike charges, the lines of force will be in this direction. Repulsive force. Got the idea? So try to look at this lines of force for unlike charges. Then if two unlike charges of magnitude, say plus 2q and another is plus q. Then again, the number same here, if I assume 16 lines, then here 8 lines of force should come. And the lines of force, I'm showing it in this way. Got the idea? Okay, one more small, very important information. Let me share it. Then I'll come back to this one.